coupon codes. Okay, so that's me done. So I'd like to hand over to David. Who's going to talk about Docker in production. Okay.
Hey. Hello. All right, a bit more enthusiasm would have been good, but I'll take it. I'm here to talk about Docker, so we'll start with the obligatory holding your hands up. Who has used it? Oh, shit. Who's used it in production? Awesome. I can handle that, right? My name is David. I am a software consultant and the organizer of Docker Glasgow, so I like to think that I know a thing or two about Docker. I'm also organising Scotland PHP. When anyone wants to speak about either of those things after, I am more than happy to have 12 beers and do so. I have been running Docker in production now for just over 2 years at quite high scale, so if anyone has that challenging problem, I'm happy to talk about it. But for today, what I really want to do is kind of give everybody some tips about how they can actually start to roll this out in production and deal with some of the problems that come along. Well, a lot of problems actually come along, but we'll deal with some of the more common ones. And we'll start firstly with kind of why should we use Docker, right? Is anyone still using Vagrant or even worse, FTP? Nobody's willing to put their hands up. So the main reason I like to tell people to use Docker is because onboarding becomes such a trivial affair that you can actually have somebody come into your place of business, turn on the computer, install Docker, run one command, and they have your entire development environment up and running, which I've been to many companies over the last 15 years, and I remember the days of actually installing all these things manually, and it was quite dreadful, to be honest. Something that we've been kind of trying to deal with for the last 10 years is this idea of development, staging, acceptance, and production parity. And what I mean by that is that, we actually want a bit of confidence in our code, that when we run it in development and we run our tests, if we have any, that same outcome is going to happen in all of our environments. And we're not going to deal with the age-old problem of, well, it worked in my machine, right? It's 2016, that does not fly anymore. Deploying and rollback, another awesome use for Docker and CI and CD in general, is that we are actually producing something that is distributable and runnable in under a second, ideally, if you've got your setup working correctly. So, if you're using Capistrano, you're doing composer installs and migrations and stuff like that, the chances are you've got a lot of value by taking a look at Docker and actually bringing it into your kind of production workflow. Security. One of the big kind of things that Docker's had to deal with over the last 2 years or 3 years since it's been around is that people think it's actually causing problems with their security. It's going to be hacked. It's going to have vulnerabilities. Well, true story is everything gets hacked and everything has vulnerabilities. What you'll actually find by putting your production infrastructure into Docker containers is that the attack surface is wildly reduced. Right? If somebody gets into your infrastructure, they're not getting out of that container. Well, unless you do stupid stuff, but we'll cover some of those points. But ideally, if you're running Apache in PHP or Nginx in PHP, and somebody gets into it, they're not getting to your host, which is where all your private data is, and your network. And friendly fire. I don't know how long you've all been developing, but I've made changes on production infrastructure through Vim before and killed other services I didn't think I was even touching. So we get this kind of security from ourselves as well, by keeping things in containers, and more importantly, keeping ourselves and our colleagues out of those containers as well. Auditability is not really a big problem for most people unless you're working in finance, but something really cool that I've found over the years is that if you ever have a security breach and you want to know what your infrastructure or what your production servers looked like 18 months ago or 6 months ago, or God forbid your monitoring's that bad and it was 4 years ago, you can actually pull the container out, the entire image, and get an exact snapshot of what was in your production infrastructure, rather than just going, well, our Git code base looked like this, but that doesn't really mean anything when it comes to production servers. And better allocation of resources. So if any of you are dealing with scale, you've got auto-scaling groups on Amazon or Google Cloud, then you're maybe spinning up an entire VM to run an application. Maybe it's on like a C4 large, but it only really needs a T1 micro or something like that. Then when you start to work with containers, you begin scheduling containers on VMs rather than booting up VMs to run your application. So there's all of these kind of benefits. But of course, there's no such thing as a free lunch. Docker is not easy to implement. There are a lot of concerns, problems, gotchas, and things like that we all have to be aware of, as with any new technology. So this talk is going to cover probably the number one question that I get, which is how do I actually take the first steps? What method of orchestration am I going to use to give it an image and say, run this on my production infrastructure? And then once I've covered some of these tools, we will go into the kind of tips and gotchas that I've dealt with over the years as well. So here's your options: ECS, Swarm, Kubernetes, OpenShift, and Mesos. So ECS is the tool that is provided by Amazon. So if you're running on AWS, this is a very appealing option because you don't actually have to manage any infrastructure yourself, which is cool. It does handle load balancing, and that you can create an ELB and assign it to your service, which is pretty good. You don't actually need to spend any time configuring HA proxy or I don't know, Nginx to do some sort of reverse proxy. And I don't know what your setup is, but this becomes very trivial. And anyone that's used ECS or tried to use it in the past, it didn't actually handle the container level scaling. So you used to have an auto-scaling group that would spin up VMs, but you couldn't tell ECS to put new copies of your container on the new VMs. I tried some various hacks for a while, such as running Lambda events, but as of maybe 6 weeks ago, Amazon now handles this for us. So that's a couple of benefits of running ECS. If you're not running on Amazon, that's kind of pointless. The problems with ECS are that it's actually running a particularly old version of Docker. An old version of Docker is probably about 3 weeks. It does change very, very fast, and it's something you kind of have to get used to. I think at the moment, ECS is running Docker 1.8. And just to kind of give you an idea, at the moment, Docker is on 1.12. So, it is a good few versions behind, and it does evolve quickly. Deploying to ECS is also very non-trivial. You either have to use the admin console, update your task definitions, update your service definitions, and then tell it to do a deploy. There is the AWS CLI, which some people like, but composing JSON to actually fire to that is an absolute nightmare, and I don't recommend it. Another problem with using ECS is that you have to adopt this service only runs on this port, which means you can't run a service more than once on any VM. Not exactly the best allocation of your resources. So it's kind of a give and take. If you're on AWS, I'd say consider it, but there probably is a better option. Next, we have Swarm, which is the orchestration tool by Docker themselves. What's really cool is that very recently at DockerCon, which was 2 weeks ago, they added an entire bunch of new features, which means you can actually use Docker Swarm without an additional download. This means you can use your standard Docker CLI to create a swarm, register new instances, and launch tasks, which is very cool. Another very cool thing they've done is they added load balancing, and it's done in a very cool way using some sort of fancy mesh routing. I don't fully understand it, but it does allow you to just have your service available in any port, and any Docker engine will redirect it for you, which is obviously very powerful. And one-click everything. With Swarm, you can deploy new versions, roll back, scale up to 100 nodes, or scale down to a single node with a single CLI command. Looking pretty good. Unfortunately, you need to be running the latest and greatest version of Docker, which isn't exactly capable for everyone. It does change very fast, so you are going to get backward compatibility breaks, and nobody has ran production Swarm yet. So there are no case studies to say that if you want to run Swarm in production, you can handle X million traffic per month. So kind of take that one with a grain of salt. Then we have Kubernetes. This is the orchestration tool by Google. And it is the everything and the kitchen sink bit of software that is available if you want to run Docker containers in your infrastructure. I say that, and at Google, make sure you do not have to worry about anything. You can just install Kubernetes on your hosts, and it'll handle anything you want, whether that be load balancing. I've got planet scale in quotes because it's actually what Google say. They say they use it, and they can handle the scalability of everyone on the planet, so they're calling it planet scale. Another cool feature that isn't found in other orchestration tools is that we get secret and configuration management. So you don't have to run things like Vault or Console or etcd. Kubernetes is going to provide all of that for you. And another very cool part of Kubernetes is that it actually offers a load of remote storage drivers. And by that, I mean that you can tell it that in your container you need an NFS mount, a Amazon S3 mount, or any other remote kind of file store. And it'll handle that for you at container launch. And as I say, it offers everything. The downsides are it offers everything. You can't just run Kubernetes and use little bits of it. They make it particularly hard. You also have to adopt their vocabulary and their idea of a pod. So you have to split all of your services into these task definitions, which are called pods, and scale them up kind of linearly like that. So if you've got a whole bunch of workers, it's probably a little bit harder, or maybe completely overkill for what you need, but it's still definitely a viable option. OpenShift, if any of you are running on Red Hat, then this is their supported version of Kubernetes. So, you know, if you're paying for that license, you might as well embrace it, get the free support, and not have to handle much of the operations. Mesosphere is probably one of the bigger ones next to Kubernetes, but I haven't really played with it a lot. I say that DSOS is cool, and that's their data operating system for the cloud. So all you really need to do is get the AMI ID from AWS, put that into your launch configuration or to Google Cloud Compute, and it does everything for you. It'll spin up instances that are running everything you need, and you can run some CLI commands to run containers on it. It doesn't really do anything on its own. If you want to actually orchestrate applications on top of Mesos, such as your own Nginx, HAProxy, Elasticsearch, MySQL, then you have to install Marathon on top of your Mesos cluster. Not really that hard to do, but it's just something else that you have to manage. So that's orchestration. Does anyone have any questions on the tools I mentioned that would like me to clarify anything before I move on to the real production information?
I'll ask a question. I know about all this stuff, but maybe for some people who are not familiar, can you?
There's a mic there if you want it, man.
For someone who wouldn't be familiar with those tools, can you explain how it correlates with the regular life of PHP developer? Where can they get to see Docker and how would be the first time they use it?
So how do these tools help a PHP developer that maybe doesn't know what the tools are for? So I guess this comes back to some basic Docker knowledge. If you're going to start to put together your PHP application on a development environment and you want it to run in Docker containers, when you make that jump to production, you need a way to get it on, right? You can't just magically get your container onto a production machine. So these tools really just provide a really simple abstraction or a CLI or a RESTful API or anything where you can say, I want you to take version 10 or 12 of my image and run it in my production infrastructure for me. They all do it in slightly different ways. I've kind of covered the good and the bad. So, you know, there isn't a single solution that's going to fit every team in here. If you're running on Red Hat, OpenShift is obviously a no-brainer. If you're on AWS and don't want to manage infrastructure, use ECS. And if you're feeling Gallus and don't want to have to deal with load balancing and service discovery, use Kubernetes.
You need to explain the term Gallus.
Sorry?
I think you need to explain the term Gallus.
Oh, is that my Scottish accent coming through? Gallus means brave, right? Right. Any questions on orchestration? No, right? Right, cool. We'll come back to some stuff later on. So my first gotcha of the night is These tools are really cool, but let's only get to using them if you really need to. Right? If you're running your application on one VM in AWS, don't get bogged down with trying to scale yet. Really just use the tools that you've got already. If you're deploying with Puppet, SaltStack, Chef, or even Ansible, whatever, use that tool to pull your images to the machine and run them, rather than actually going down a container-only solution, right? You know, baby steps. There's no need to start managing all of this infrastructure so early, because I guarantee you it's not easy. Once you start running orchestration tools at scale, you have to start worrying about quorums and running 3 to 5 to 6 different versions of a single node just to manage your containers. So avoid it for as long as possible. Service discovery sucks, to be honest. It's not a problem that anyone has really made easy except for Kubernetes. So, you know, if you're using that, then ignore it. What I would suggest is you pick a single port for each service or application, depending on your architecture, and stick with it. A really good solution I used to use was we had our CMS, which ran on port 6601. And I ran it on 6601 regardless on every machine, or at least any machine that I needed it on. And my trick was I added every VM to the load balancer. So the load balancer maintained the state of which machines can I throw this to, and I got load balancing and service discovery for free. So that's quite a cool wee trick. Port-based. Docker events. So you're going to have to start doing monitoring of some kind, right? You know, you might be running Sensu or Prometheus or anything that's checking your infrastructure to make sure your machines are online. How do you make sure your containers are running, right? There's a difference between this container running my application and this container is actually running my application and working. A really good way of doing this is Docker provides through the basic CLI an events kind of command, and it'll spit out some information like this. So you can see in the green that Docker has different events that we can monitor. So we've created a container. We're attaching to a container if we're doing something that's kind of interactive. Connecting to the containers is the second stage of the attach. And then we've got a couple of very obvious events there: start, die, disconnect, and destroy. So we can actually just run something very simple, polling this API, or even it's got a -f follow. And you can start to build reactive infrastructure just around this itself. So you don't need to do anything too crazy or too complicated just to make sure your containers are running. You can also use Registrator. Registrator is a tool built on the Docker Events API, which just runs on your host and will monitor these events for you. One of the things that Registrator will do is if you start or kill a container, it will actually reload your Varnish or your etcd or your console configuration, however your setup is really running just now to do this kind of stuff. So Registrator is a really cool tool, but if you don't want to add in extra concern, just use the Docker Events API yourself. I mean, we could all probably throw together a PHP script in a few minutes that just responded to those. Logging. This is probably the bane of my life for the last few years. Logging is very, very difficult. So just for context, I started using Docker in production when it was 0.4. It's not a good thing. It broke all the time. But we done a lot of crazy hacks back then to get our logs out of those containers, right? You know, we were trying to use Logstash. We're trying to use Elasticsearch and Kibana. And the problem with containers is that our applications are running in a container, creating logs in a container that we don't have access to on our host. You can do crazy things like mounting some sort of host volume, but generally I try and say avoid that. It's quite messy, it's quite clunky. And definitely don't run remote syslog in your container. The problem with running an extra process inside your container is if you're running Nginx, FPM, Apache, whatever your infrastructure is, and you're running this other process, Docker doesn't know when that other process dies. So I've seen a lot of people that do run, in fact, I sometimes run Nginx and FPM in the same container. The problem is if Nginx is still running, Docker thinks that container is healthy, even though FPM is dead and isn't satisfying any PHP requests anymore. The same happens with remote syslog. When that dies, you probably don't want that machine or that container running anymore because you're not getting any logs from it, especially if that's critical to your application. So generally, just avoid it. Don't use the volume mounts. You're just going to end up with a metric fuck ton of logs on your host. You're probably going to fill up the disk days, months, years, however long it takes, and that VM is going to die. So, fortunately, since Docker 1.6, they actually handle all of this for you, so you don't have to. So they added the concept of the log drivers, and it covers pretty much every logging scenario that I've seen in anyone's production infrastructure. So you can have it output a JSON file to some remote location. You can have it use syslog on the host, which is quite a good option. Fluentd and AWS logs are really good, and then so is Gelf, which is logs dash and Graylog. I don't think anyone here is probably running anything beyond that. The only thing I would say, if you are in AWS, avoid AWS CloudWatch logs. It's very poorly done. Every container gets a different stream, and those streams are really hard to search through when you're looking for a particular error. You know, maybe like 500, you want to pull them all out and do a wee bit of research. AWS logs just isn't going to work. So I generally just suggest you all run elk. So another gotcha. Docker changes really fast, and that's probably like the third or fourth time I've said that now, and it's because it's so true. Just in the 3 years, you know, they've been through maybe 60 different versions, and those are always, not always breaking backwards compatibility, but always adding new things that kind of reduce the use of the older APIs. So they're quite cheeky. They don't break stuff, but they definitely make you want to upgrade very fast, which is quite cool. But Docker 1.12 has been out now for a few weeks, and it has a lot of really cool features, and some of those are coming up in just a moment. So, end-to-end encryption. This is a bank. I'm assuming some of you are working in the financial sector, or some of you just have a lot of concerns around security for your application, maybe for your users. So as of Docker 1.12, they've actually changed the entire networking stack, that every communication between a container and a container is now completely encrypted, which is very cool. They've also added the mesh routing, which means if you browse to port 80 on one container, it can actively redirect you to another container that actually has that port open, which is how they do the load balancing that I was talking about earlier as well. Private registries. So if you are running Docker in production, the chances are you're going to have to put your images somewhere. Right? There's not really any way around this. Don't try and do this yourself. There are major problems with the way that the Docker private registry works, and that you can't actually delete old layers. So if you think about a Docker image, you get your base, and you build on top of it, and you build on top of it, and you build on top of it. The chances are you're going to hit the 60 images. If you're doing CI and building 2 or 3 times a day, you're going to do that in a couple of weeks. All of those layers and all those images are going to add up. On average, I would say that a Docker image is probably 300 to 450 meg. So you can start to see that in a month, you're going to need a few gig. And then you're going to keep building on top of that, and you're going to fill up a disk. One of the places I was working with as a contractor were building their CI pipeline and all of their branches. So not just development and master, but every branch that ever had a commit was getting a Docker image built, which worked out at around 300 to 400 images a day. And they ended up using 2 terabyte in the first week. And then they asked me, how do we delete the old layers and images that we don't need? And the realistic answer is you can't. Docker are aware of the problem, and if you find the GitHub issue for it, there's like 300 to 400 comments. It's been ongoing for over 2 years. The problem is they don't know how to do it. The layers all work in a graph format, and they can't work out when a graph or a tree is now redundant, and you're stuck with this kind of space. So that's a long version of saying just don't do it. There are other options. You can use Amazon ECR if you're on AWS, which is their managed private registry. You can use Docker Hub's private images. It's like maybe $10 a month to put a couple of private images on it. I think Google Cloud Compute offer their own private registry. And then there's loads of other services online, such as key.io, and I'm sure there's a few others that are kind of escaping me. But don't do it, right? You will have a very bad time. Sign your images. So I've never witnessed this, but when you work with Docker enough, you realize just how easy it would be to actually interfere with someone's image. Like if you're pulling from a registry, most scenarios I've seen is that people aren't running their registry on HTTPS, and they're not verifying the image that they get is the actual image that they built. Now, Docker realized this was a problem at the last DockerCon, which was a year ago in March or April, and they released a tool called Notary. The really cool thing about Notary is that you don't have to use it with Docker images. If you have a CI or CD process where you're just building a tarzip or a FAR or anything like that, you can actually still sign it using Notary. So take a look at it. It's really easy to use, and you can actually give YubiKeys to all your developers, and they can sign the images as they build them. So it's a really cool security thing. You don't want to pull down something that's got some sort of crazy bash script in your Docker image, so it's quite a good approach. If you can't use Notary for whatever reason, do make sure you're running SSL on your registry and make sure there's authentication. The bad part about that is you can't actually run authentication as standard with the Docker private registry. You actually need to run Nginx or HAProxy in front of it to handle the termination and then pass on. So there are some serious downsides to running this kind of stuff. Read-only. This is an awesome flag. One of the things I see a lot of people doing is using the Docker exec, going onto their containers in production and making live changes. I've even seen people running Symfony applications, make changes, and then clear the cache. I cannot tell you how bad that is, because the chances are you're clearing the cache's root when you Docker exec on, and then you're killing your Symfony application. I have seen it many, many times. So generally just avoid it. Don't exec onto any production infrastructure, and just stop anyone from the get-go by getting on and run it in read-only mode. Means anytime they try and make a change to the container on a live environment, it's going to say, no, you can't do that. ICC. So this is a horrible, horrible feature in Docker. And what it allows you to do is, should you ever be on any VM within your Docker network, is that, let me back up. If you're on any Docker VM, you can connect to other Docker containers that have been linked together, right? Chances are you've not done much digging into what the link does when you run multiple containers, but all it really does is edit the hosts file on every container with an IP address and the name of the container, right? So if you go into one container, MySQL, when you want to get to another container called PHP, it's throwing the Docker IP into the host file. So it's not really a link. But this ICC flag is on by default, and what it allows you to do is port scan or just ping every IP address on the subnet, and you can actually SSH or speak to it without ever saying this container can speak to that container. Not ideal. So if you're running your database in a container, you're running your PHP in a container, and you're running your Elasticsearch in a container, if anyone should ever get access to any of those with any sort of malicious ideas in their head, they could then start to fuck around with other containers, even though you think they're safe because I've not linked them, right? So just disable this on all of your hosts. As part of the Docker engine parameters, so it's very easy to change. You just do --ICC equals false. Golden rule, containers die all the time. The technology is relatively new in its form. I mean, obviously, we've got C groups and namespaces which are particularly old, but the Docker container itself is pretty new. And they do die. You know, there are seg faults. They do run out of memory if you're using the memory limitations. If you've got some sort of CPU share thing going on and it conflicts, it's probably going to die at some point, and that's okay, right? We want our infrastructure to be a bit more resilient than that anyway. So Docker offers a really cool flag, -- restart, and you can just tell it, if this container dies, I want you to try and restart it this many times. And then if you go beyond that, you've always got your Docker event log that you're all subscribing to send you an email, send a push notification or anything like that. So just always think about, how can I make these containers work in an environment where they're probably not going to work. And some other cool flags that I don't think I've ever seen anyone use is that you can actually tell Docker how to monitor the health of your container. Right, so are you running Apache and it's open on port 80? Right, okay. How can I test that? Right? Well, I can send a packet to it and see if it responds. I can send a request to it and see if it responds. If it's something else, then just create a small bash script, stick it into your Docker image, and have it run every 5 minutes, every 30 seconds, whatever you feel comfortable with, and Docker will restart that container for you when it fails. It's a really cool option, and like I said, I haven't really seen many people using it, but it does save you doing a lot of other boilerplate around keeping your containers alive. So it's a really cool option. File systems. So if you've ran Docker at any scale or even on dev and you're running on a Red Hat distribution, what you've been doing is running your Docker system on device mapper. So every time you run a container or you create a Docker volume, you're creating this device mapper layer that it then manages on the host for you. The problem with device mapper is that it sucks. If you are rotating containers 10, 20, 30 times a day, or maybe even less, when you delete that container, you think you're deleting the volume attached to it. Unfortunately, device mapper doesn't really work that way. You could run 4 containers and find your disk is full. Seems to be a common problem with Docker, but especially with device mapper. If you can, upgrade to a 4.0 kernel and just switch to overlay FS. It handles everything much better. The volumes actually delete when you want them to delete, and you're not going to run out of disk space every couple of days and end up killing all your VMs. Or even worse, your local development machine. No? No, okay. I have been running overlay FS in production for a while. Sorry? Oh, all right, okay. No, we don't use that shit, right? That's owned by, they built Rocket, so they're dead to me. No, I haven't came across any inode problems running overlay. I did successfully, for maybe 9 months, run an OFS, which worked amazingly. But unfortunately, it's not part of the standard kernel anymore, so you have to compile it afterwards, and I just decided it really wasn't for me. And I've had nothing but good things to say about overlay FS since I switched, which has been probably just under a year now. But if there is an inode problem, don't run CoreOS. In fact, just don't run CoreOS, right? Just Alpine Linux. If you've never used it or never heard of it, you should check it out. Massive images. I don't think I've ever been anywhere that I haven't seen this. Now, the way that Docker works and the way the layering works is that it's a copy on write file system. This means when you run a layer, when you then add a new file, it adds a new layer. If you add 10 more files, it adds a new layer. What Docker doesn't do, like kind of Git does, is know what changed for each layer. So if you do a chmod or a change own inside of your image or your container, it's actually going to duplicate that entire layer. So I'm sure you don't, right? But if you add 700 meg of PHP files to your var ww folder, and then you run your change ownership or your change mod command, you've now got a 1.5 gig image, right? If you do that more than once, you're ending up with a 3 gig image. And this escalates very, very quickly. So just never use those commands in your Docker file, and you'll have, hopefully, a relatively happy time. If you do need to change your permissions, which you probably will, because let's face it, you're putting on these app and cache and log directories, well, they need to be owned by www.data. Unfortunately, even if you say user www.data in your Docker file, and then add loads of files, they get added as root. They are working on it, but they don't really know how to handle the user mapping yet. Again, it's one of these things where if you look at the issue queue, it's got like 300 or 400 comments, and it's been ongoing since Docker started. So what to do is to create a very small entry point script, and every time you run your container, just do the change ownership there. It won't affect your Docker image size, and you'll still be able to run it without any permission issues. So that works really well. Secret management. I've seen this loads of places as well. People have API keys. People have all sorts of secret database credentials, all stored in some sort of Symfony or Laravel configuration file that they just pre-bake into their Docker image. Now, your servers might never get hacked in production, but if anyone get access to your unprotected Docker private registry running wherever it is, they also have access to your database host, the username and password, they can log in, they can drop all your tables, you know, all the bad stuff in the world. So there's a really cool website called 12 Factor. It talks about how we build applications that are a bit more modern, and this is actually a really good fit for Docker because it encourages it out of the box. So instead of putting your database host IP, your username, and your password into all of these files, instead have it reference environment variables that you can pass in during your Docker run, and you're going to have a much better time. And it also means if your image ever gets compromised, they don't have access to anything except your source code, which hopefully your business doesn't rely on for money. But, so Docker's a trade-off, but just keep it secure as much as you can. Unbolt. This is an awesome flag. Is that a question?
If I'm running a farm of multiple machines, how I distribute the environment information to the host machines?
So I'm assuming you're using some sort of Ansible or Chef or Puppet to run these things on the host, right?
Yeah, so if I have like 10 servers and each of them running Docker containers, how do I distribute my environment variables to those host machines? Is there a good way?
This comes down to whatever orchestration tool you're using. So if you're using Kubernetes, you can store them all there. If you're not, one of the tools I use a lot is SaltStack. And it's got a concept called pillars, which is just parameters that I can pass to containers when I do my orchestration. And those can live in Amazon S3 buckets, MySQL databases, and anything like that. If you're using something like Mesos or even just something like Puppet, I don't know if Puppet has secret management, I'm sure it maybe does. You just use this tool. Ansible's really good. It's got group vars. If I've not mentioned the tool that you're using to manage this stuff or even manage your deployment and you don't know how to do your secrets, just grab me and we'll come up with something. But there are many, many ways to do this. It really comes down to what tools you're using, what infrastructure you've got, and how you want to manage it. Privileged. This isn't really a concern anymore. I think maybe 6 months ago, Docker started to add capabilities to the Docker engine, which means you can actually run your container with the permissions that it needs. So it used to be that if you needed, for whatever reason, your Docker container to access some sort of /dev device from the host, you would run it in privileged or you would mount that directory in. Now, that's really bad, but I have seen it. You don't need to do this anymore. You can, in fact, just say capabilities network, and it will allow it to do some basic networking things. You can pass in other capabilities depending on what you have to do. Another flag I've seen abused a lot is -- host. And this actually runs your container using the host network rather than creating the virtual bridge. This is particularly bad as well because you're pretty much just saying, you'd be as well just running your software on the host without Docker completely. You give it access to everything on the host, including the host network, which means it can speak to any machine in your infrastructure, depending on your IP tables. So avoid these two flags. If you do have these running, just say, right, why do I need host? Like, maybe you need to link it or pass in some sort of link to another container, then just do that. One of the main reasons I see people using -- host is because they work in an environment where there's maybe custom DNS on the host that doesn't live inside the container. Or maybe you're working in a Windows domain or a Linux domain where you need it to search a domain controller to get to another machine. Docker does have options for that too. You can just pass in --DNS or --DNS search, give it the domain, give it the IPs of your DNS, and it'll do it for you. Now, you don't ever need to run --host ever again, hopefully. And random ports. This is the best option ever. Don't think that just because your Apache container defaults to port 80, that you need to run it on port 80 on your host. Just let Docker pick something at random, handle the load balancing through Kubernetes or whatever other tool you want to do, Docker events or registrator, and then it means that if you want to run 10 versions of your application, or maybe you've got a Beanstalk worker or a RabbitMQ worker, you don't really care if it's available or load balanced, you just want as many of these things to run as possible, then the random port is going to allow you to do that. If you stick to fixing things to the native port, or even if you say, I want to expose all my Apaches on 6.601, you can only run one per VM, right? It's not a really good way to do it. So if you just do -p and say expose this port, it'll pick something random on the host and assign it, and you never have to worry about it. Community images. This is how we all get started in Docker, right? We all think, right, this is a new tool, I want to play with it. How am I going to do it, right? Well, I'm going to run the default Apache image, or I'm going to get MySQL up and running on my machine without ever installing anything besides Docker. So we go to the Docker Hub, we find community images. The story that bit me pretty bad was I was working for a media company, and we ran the Atlassian stack. So that's Jira, Confluence, Bitbucket, all that. And I got really, really fed up of installing these things because they're big, massive Java applications on all my VMs. I didn't really want to pre-bake an AMI, and I thought, this is an awesome, awesome reason to use Docker. So I found some community images that had already been set up to run these bits of software, and I started to run them on machines. And they worked perfectly, right, for about 6 months. And then it turns out that the people that made the images got a cease and desist from Atlassian. I showed up to work on the Monday, and my entire infrastructure was down. We had no Jira, we had no Confluence, we had no Bitbucket. Fortunately, we were using Docker volumes. I never lost any code through Bitbucket dying. I never lost any Jira stuff because the database was all in RDS. But community images will disappear. Obviously, Atlassian was a brave move because they were probably going to do their own at some point and ask everyone else to take theirs down. But just don't do it, especially if you're going to run these community images in production infrastructure or just anything that you need it up all times. Either copy the Docker file if it's available or create your own. Never rely on them. You can rely on the Docker official images. I've never lost one of those yet, but you know, I randomly keep backups just in case. So avoid it. And finally, composer log files. Please, I know it's contended and this view is kind of bad, but see if you're doing CI and you're committing your composer.log file, you're really saying that you don't care about security or upgrades, right? I have worked on large projects where I've committed the log file and I thought I was saving myself lots and lots of headaches. But all I was really doing was running very old packages that I never updated because it became too hard. The great thing about Docker, as your CI and in your production, is that when you do your build, you do the composer install, you're always pulling the freshest versions, and they live forever in that image. Like they're never going away unless you delete them all from the registry. So there's absolutely no reason you should ever have to commit this file. So just stop it, right? That's my best advice to everybody. Yo.
That question about composer.log, for example, recently PHP 7.5, like a 7.05, been released with a SPL bug, and couple Zen packages was the kind of crashed. And basically, if I wouldn't like a commit composer.log, all CIs would crash because they fetch an invalid dependency, and dependency break your build. So maybe
you're supporting my don't commit the log file, right?
Pardon?
You're supporting me in my don't commit the log file.
No, basically, I think I shouldn't commit log file for library because it does make sense. But whenever it's an application, like what's going to be deployed, I think it makes sense to commit a log file.
No, I have heard this argument before, and you know what? Before Docker, I completely agreed. Because when I deploy, I don't want to have to worry about whether this is going to work, right? But when you have a Docker image that's got all your dependencies and your test suite is ran and it's passed, I can't see any logical reason why you would commit it anymore.
Yeah, I understand. Like, but that is an ideal world whenever you have 100% coverage. Whenever I do some stuff,
coverage. You just need confidence, right? I mean, we all take risks every day in our jobs. That's what we do.
Okay, fair enough.
If you have, sorry, on you.
So I was wondering how you handle disk-heavy services. So things like databases, That's the only thing I think of off the top of my head. But like stuff which requires lots of storage, because I've found it a little bit flaky with Docker.
Yeah, I would 100% agree. Running databases in Docker, I used to say don't do it, right? That was my default answer, just don't do it. Databases are too important. But I've now moved on from that. The Docker volume support and the plugins is very good. You can use tools like Flocker that will keep all of your database remote storage somewhere else. You can mount an SBS disk to the VM and keep all your database files on that, and it works amazingly. And it means that you actually get the flexibility to spin up your new version of MariaDB, see if it kills your tests, and it doesn't, right? Or you can switch back to MySQL, but it's owned by Oracle, so we don't do that. So try it. If you want to run your database in a container, I'd say go for it, set up the volumes correctly, and you'll probably have a brilliant time. If it breaks, don't come speaking to me.
Apologies for so many questions.
Do you work for Docker?
I have this weird annoying thing whenever I deploy a container, when it gets built, it pulls the latest version of Ubuntu, but then it issues the update command, and it starts updating packages, and there's 100 of them still being updated. I'm wondering if it's the latest container it pulls in the beginning, why there are so many updates on top of that, and what is the best practice to get something which actually will not be updating so much?
I think what you said was when you do a Docker build, it's actually fetching the latest version of the base image.
Yeah, so in my Docker file, one of the first two commands is get update and update upgrade. So it fetches a lot of packages.
If you're running that on a new VM that hasn't been built before, it's obviously going to have to pull down the Docker image. But if you're running that Docker build on a machine where it's done it before, it's going to use the cached version. It's not going to pull down the latest version of Ubuntu. And then it will use the cache for your Docker layering, and it will only probably do the steps after you do your add code, right? So maybe you've just got the Docker file in the wrong order, though it doesn't really sound like it, but maybe worth checking out.
Well, what it does, it does cache, but then if I add a new package, then it usually just starts breaking,
Oh, yes.
and I have to manually rebuild it.
Yeah, so if you add a new package to the apt-get install line, then you're invalidating that layer, so it's going to have to do the apt-get update again regardless. Is that what you were saying?
Yeah, and I have to somehow trigger the rebuild of the cache again from the beginning, because I can't just put yet one more package, because it's out of date, and I need to do the update again because the cached version is out of date. The URL is incorrect.
Welcome to Docker. I mean, the Docker layers work like if you were building a tower of Lego. Oh, now it's locked. It was the last slide anyway. So the Docker layers work like you've got a Lego tower. So you start with your base, you keep building up and up. If you want to change anything from the first layer, the second layer, the third, you invalidate everything above it, right? So if you change the apt-get or apt-get update line, you're basically saying, I'm rebuilding this from the start. So you just have to get a little bit more smarter about the way that it does it. Something successful I've used is the Onbolt. So you can really just bake what you consider your base. I'm never going to change this image, but make sure it still builds regularly, right? You want security updates. And then put anything that you think is going to be variable or changed relatively frequently into the child of that. And then you'll find that you're doing a lot more caching with the Docker layers and a lot less rebuilding all the time. It's just a science. You've got to play with it and work it out, and it takes a bit of getting used to. But if you want to send me your Docker file, I'll be happy to take a look. So as I said, I mean, there was only one slide which just says thanks and any questions. So if anyone's got any.
It's just about the last slide about the composer lock. I tend to disagree with you because, like, basically, the dependencies that you have is basically another person that is committing a new version or a new thing to master, right? So they might introduce an error, and I understand that the Docker tends to not be changed. So when you build a container, you don't change it. That's fine. It's tested. You can revert it and upgrade and.
You're like 2,000,000% correct, right? We do rely on other people maintaining their open source projects for us to consume in our application. And that's our responsibility to do proper version pinning. So if you're using Doctrine deball, and you want version 3.5 and you just have the wrong pinning and you get 3.6 with a backward compatibility change, you know, right, okay, I need to pin this to version 3.5.
Yeah.
The point is, like, we use so many applications in our composer file, so many dependencies that could all have 100 different security vulnerabilities that could at any moment give somebody complete root access to your machine or your container if you're using Docker. But either way, that is something that you shouldn't have to deal with.
Yeah.
So if you don't commit the lock, you can guarantee you're always getting the latest and safest versions of those dependencies. And if there is a backward compatibility break and it breaks, pin it to the version that works and try and upgrade.
Yeah, I agree. But in the same way, you might have, in our case, we have a package that is API grid. So we had to stick with a specific version because basically backward compatibilities was not met by the provider. So you need to basically stick to a version. And because you don't have like the full coverage test, and you don't need to spend like the 2 weeks
I only have
QA
10%
test.
coverage, but it's the best 10%. Like,
I understand that, but the thing is, you don't want to spend, you don't want to take the risk of deploying something that might broke your production just because you don't have a lock in your system.
yeah, I mean, if it makes you feel uncomfortable, obviously don't do it, right? We all want to be able to sleep at night, and it's not worth it if you're going to go home and go, oh, shit, I don't know what's going to happen.
But in this case, you can also specify a specific commit in your composer JSON. So
I have seen people do the hashed commit. I've seen it with Sonata a lot, which is going through some heavy development and causing a lot of pains in the current place I'm actually working. But yeah, I mean, do what you need. But just, I would say avoid it as much as possible because you do want to be security conscious. But if you've got something you just can never have upgraded, just deal with it. Yeah, sorry.
Okay, I think we're going to have one more question, and then we're going to have to wrap it up. I'm sorry. So, you.
I was only going to agree about the composer.lock. The other thing we found as well, if you copy your composer.json and do a composer install, then copy your source as another Docker layer, then do a composer update as another layer, you can bring your build time down from 10, 12 minutes down to about 2.
I would argue that's the wrong way to do that.
I was just about to ask you, is that the wrong way to do it? Yeah.
Yeah, don't. I mean, why would you be doing a composer install then adding your source? I mean, is your composer installed locally? Like, you know, so if it's your development environment, do the Docker compose locally, right? Because you want that cached. You want your development environment to be fast. But your CI process, your build process, should be adding the source, doing a composer install, and that's it. So then you shouldn't have that problem.
But isn't it same effect, or don't you think?
No.
No.
Because your composer install is adding new files. It's not changing permissions of your source directory, right? So you're still only incrementing the size of your image with your vendor folder. You can't avoid that.
Okay.
Okay, I think that's we're going to have to wrap up there.
Yeah, okay.
So, big thank you to David. So. I'm not sure if anyone wants to go for a drink, but we usually go to the Christopher Hatton, which is just over the road. So, if you've got any more questions that you've not had answered, I'm sure David will be happy to answer them in the pub. So, thank you very much, and I'll see you next month.